All right, so today we are going to look at more derivative rules. In fact, we have very few derivative rules. There are very few functions that we can differentiate by hand at this point. So we're going to start to move forward on that. So today we're going to talk about how to differentiate functions that are products and quotients. So let's just jump right in. It says, let's look at this function, y equals x squared times the quantity x squared plus 4x. Do we know how to differentiate this? And to be honest, as it sits right now, no, we have not talked about how to deal with products. However, we could distribute that x squared and call it x to the fourth plus 4x cubed. So now we could take the derivative to get 4x cubed. So we can eliminate that product and take the derivative with the power rule. However, could we use that method on this function, y equals x squared times the sine of x? And the answer is no. Why? First of all, we don't know the derivative of sine x. That's our first hang up. Secondly, we can't simplify to get rid of the product. So I'm going to just write not yet. Okay. Well, it says, could we do this? No, we can't distribute an x squared into that sine x. So this kind of leads us into saying we need a rule to deal with products. It is called the product rule. All right, so let's write this rule down. The product rule says, how do we take the derivative of a function f times g? I'm not even going to put the of x in there, like it's a little cumbersome. So just in general, what is the derivative of f times g? Looks like this. It will be f, we leave f alone, then we multiply by the derivative of g. So it's f times g prime plus g we leave alone, and then we multiply that by f prime, the derivative of the first factor. I know that looks a little bizarre. The more we practice it, the easier it's going to get. Okay, and I wouldn't necessarily memorize like f, g prime, g, f prime. You're going to hear me say things like the first times the derivative of the second plus the second times the derivative of the first function. That's kind of how I do it. Now, the other way to think of it is, all right, we've got two factors. We leave one alone while we take the derivative of the other one, and then we switch places. We leave the other one alone while we take the derivative of the first one. It doesn't matter which order because it's multiplication and it's addition. So actually doesn't matter the order. All right, so here we go. It says differentiate each function by either simplifying first or applying the product rule. I'm going to be honest with you. I'm going to use the product rule so that we can practice this new rule. So they're asking us to take the derivative of this. So I look at this as one thing times another. Look how I differentiated. Look how I just kind of cleaned up that I have two things, two factors. So the product rule says we leave the first piece alone. So I write down x plus 1. Then I want to multiply that by the derivative of the second piece. The derivative of 3x to the fourth is 12x cubed. And then the derivative of 4 is 0. Plus, now we leave the second piece alone, and we multiply by the derivative of the first piece, which is just 1. We can leave that alone. I mean, we could clean it up, but, Okay. Let's take a look at the second one. Take the derivative of this expression. Again, I've got this piece being multiplied by this piece. I don't consider the 4 as an extra factor because it's a constant, and we have a constant multiple rule for that. All right, so the product rule says we rewrite the first piece, and then we multiply by the derivative of the second, which is 1 plus 4x. plus the second piece, which is x plus 2x squared, times the derivative, you can't even see that, I'm off paper, times the derivative of the first piece. Now with that radical, some of us will choose to come over here and just write this as 4 times x to the 1/2, so that we can use the power rule. 1/2 times 4 is 2, and then when we subtract 1 from the exponent, we get a negative 1/2. Beautiful. Now if you want to put that back into radicals, that's up to you. Plus x plus 2x squared, and then we'll call that 2 over radical x. I mean, to me, that step is not necessary at this point, because all I'm asking you to do is to practice taking derivatives. When we start using derivatives, then I'll say you might want to clean it up first. Okay? All right. So, same kind of idea, just like we determine the need for a product rule, we will also start to see the need for a quotient rule. Quotient meaning division of functions. So it says, let's look at this one. We've got y equals x cubed plus 3x all over x. That is a quotient of two functions. Now, we can take the derivative of this one without learning any new rules because we can simplify this. See how I draw my little heart here? I'm going to divide x cubed by x to get x squared, and 3x divided by x to get 3. Now it's not a quotient, and now I can take the derivative to get 2x. So I don't need a quotient rule to do something like that because, well, because we can simplify to eliminate the quotient. But will that idea work here on this next one? No, there's nothing to simplify here, so we can't simplify this to get rid of the quotient. So let's learn the quotient rule. The quotient rule says, how do you take the derivative of f divided by g? All right, so here we go. You ready? It's going to be a little bit longer. One big long fraction bar. And in the top, we'll talk about how to memorize this. In the top, we have g, just g, times f prime minus f times g prime all over g squared. Wow. I'll give you a moment to write that down. You all don't know me that well yet, but I like to sing, and I've got a little song for this one. So I'm going to stick a post-it note in the way. This kind of helps some people memorize this. So this is going to just help us memorize the quotient rule because it's a little more overwhelming. When we think about a fraction, we've got the part on top, which is high. We've got the part on bottom that is low. So high and low. High means top, low means bottom. All right, here we go. The song goes like this. Low, 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 D high minus high, D low. That's the numerator, now divide by low, low. Get it? It's kind of weird, I know, but low D high means the bottom times the derivative, D for derivative, of the top. I'll use a red pen here. D high means derivative of the top, minus high, which is the numerator, times D low, the derivative of low, divide by low, low. Low squared, the bottom squared. All right, so you know it can be a little bit cheesy, but I guarantee some of you will hum this song, you know, under your breath once in a while. So I'll sing it one more time. For the derivative of the quotient rule, it's low, 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 D high minus high, D low. That's the numerator, now divide by low, low. All right. So that's one way to memorize this. Great. So I'll talk about how I do it or how I write it down when we get into it. Because, by the way, look at it. It's very similar to the product rule. You leave one alone while you take the derivative of the other. You do the other one times the derivative of the first. But this time it's a minus instead of a plus. The product rule has a plus. See the P's? The product rule has a plus. The quotient rule has a minus. And maybe just think of it like it has a fraction bar in it. I don't know. All right, so here we go. Differentiate each function by either simplifying first or applying the quotient rule. This one we can't simplify first anyways. I should have said simplifying if possible. So let's just practice the quotient rule. I'm going to give myself one big old fraction bar, and I can sing the song. So the denominator was x squared minus 3. I'm going to square it. What I want you to notice in the rule is that g is in the bottom, and the very first thing I start with is g. Not g prime, just g. So if I just wrote the bottom, x squared minus 3, I'm going to rewrite that on the top. So it's the bottom times the derivative of the top. The derivative of x plus 1 is 1. Minus the top, which is x plus 1, times the derivative of the bottom. The derivative of x squared minus 3 is 2x. Now, I could clean it up. I'm not going to right now. Our focus right now is just applying the quotient rule, but I know you could all distribute things. Now, on the next one, I would absolutely simplify this by drawing that heart first. I would reduce this. I would reduce this. But let's just practice the quotient rule while we're here. So the quotient rule says square the bottom. So the bottom was 2x to the 4th. I'm going to square it. Then I'm going to rewrite that bottom. I'm going to multiply that by the derivative of the top, which is 4 minus 6x. Minus the top, which is 4x minus 3x squared, times the derivative of the bottom, which is 8x cubed. I didn't see the quotient rule was going to look good in the end. It's just the only way sometimes to deal with quotients. But again, another option would be to simplify that first. 4x divided by 2x to the 4th is 2x to the negative 3rd minus 3/2 x to the negative 2nd. Sorry, I should have written that bigger, and I apologize. Right? By simplifying this first, the derivative will be super easy. I just used the power rule. And by using just the power rule, look how much nicer it is. So I just want you to be aware, right? We're going to have some options now that we're learning different rules. So we can just straight up use the quotient rule because we saw a quotient. Or we can simplify first to make the derivative look a lot nicer. They're exactly the same thing. Okay? All right, I'm going to flip it over. All right, so it says find the equation of the tangent line or tangent lines that are parallel to this line. Find the equation of the tangent lines. Let's stop there. If we need the equation of a line, we need a point and we need a slope. Now, this tells us we may have more than one point. I don't know. Come back to that. If I want to be parallel to means same slope. Oh, well, sweet. Let's find the slope of this line. So I moved the x over. Well, let's divide everything by -2 to get y equals 1/2 x minus 1. If my tangent lines are parallel to this line, then my tangent lines are going to have a slope of 1/2. Oh, that's unusual for us. Typically we have the point and we use it to find the slope. Well, now we have the slope. We're going to use that to find the point. 1/2, slope of tangent is 1/2. Where do we get the slope of the tangent from? The derivative. So we're going to solve this equation. We're going to take the derivative and set it equal to 1/2. Now, I'm writing big. Notice I have this extra slide over here. We have plenty of room. Don't feel like you need to cram stuff in. So what we need to do is take the derivative. We have this room. I'm going to go use it. As soon as my camera catches up, there we go. So let's take the derivative of this and set it equal to 1/2. I'm going to use the quotient rule because, well, because we have a quotient. So the quotient rule says we want to square the bottom. We're going to rewrite the bottom and multiply by the derivative of the top. Well, the derivative of x minus 1 is just 1. Minus the top, which is x minus 1, times the derivative of the bottom. Well, the derivative of x plus 1 is also 1. So at this point, we have all x's left. What's good, because that's what we need to find. We need to find the x coordinates. So let's clean up our numerator. So I don't need to multiply by 1, so I have x plus 1 minus x minus 1, or x plus 1 minus x plus 1 when I distribute that negative. See why I gave us some extra room here. I didn't want us to have to cram all this in. So we're left with a 2 on top and x plus 1 squared on the bottom. We're going to set that equal to 1/2. So let's cross multiply. So I have 4 equals x plus 1 squared, or take the square root of both sides, plus or minus 2 equals x plus 1. So if I subtract 1, 2 minus 1 is 1, or negative 2 minus 1 is negative 3. We just found the x values where this happens. Pause if you need to. So I'm going to go back here to where I said the point. Well, the point is either a 1 or a negative 3 for x. I could have left us a little more room there, huh? So there are two x values where the slope is equal to 1/2. We just need to go find the y values. How do we find y values? We plug into the original. If I plug in a 1, I get 0 divided by 2, which is 0. If I plug in a negative 3, I get a negative 4 divided by negative 2, which is 2. Perfect. So I have a point and a slope. So we have y minus 2 equals 1/2 times x plus 3, or y minus 0, I didn't need to write that down, equals 1/2 times x minus 1. So this was different in the sense that they essentially, they didn't come right out and say it, but they gave us the slope and we used that to go find the point. This was a big deal right here, translating that. The slope of the tangent is 1/2. The derivative is 1/2. And that allowed us to work backwards and find the x's where that happens. All right. Perfect. Let's go to these last two slides. They're together also. They have the same direction set here. It says, suppose f and g are differentiable functions when x equals 1. And then they give us 4 discrete pieces of information. Discrete means they just give us some random pieces of information, right? They're not connected necessarily, together. All right, so they give us f of 1, f prime of 1, g of 1. Excuse me, g prime of 1. And they want us to evaluate the following. It says d dx, take the derivative of this function when x equals 1. So we're going to take the derivative and plug in a 1. We've seen this before. So the first thing I'm going to do is just write this down again. 5 minus g of x times f of x. We have two terms, the 5 and then the product. Sorry, got a little shadow there. The derivative of 5 is 0 minus, now we have the product rule. Now, where we have to be careful here is that the product produces 2 terms, and we need to subtract all of that, right? The product rule says we need a plus sign in the middle. So we have the first, which is g of x, times the derivative of the second, which is f prime of x, plus the second, which is f of x, times the derivative of the first, which is g prime of x. So we really have, if we distribute that negative, we have negative g of x times f prime of x minus f of x times g prime of x. There's my derivative. Let's go plug in the 1. All I'm doing right now is replacing all of my x's with 1's. Now let's just go get all those values out of the chart. So I have negative 1/2 times negative 1 minus 3 times 4. Everything's coming out of the chart. So I have a 1/2 minus 12. You can call that negative 11.5. You can call it negative 11.5. You can call it negative 23 halves, or you could just call it 1/2 minus 12. Numerically, they all mean the same thing. Okay. Good. A little bit different there. Let's do this last one. Same kind of idea, just a different function. So take the derivative of this quotient when x equals 1. So I notice there's a 3 in the denominator. Here's what I'm going to do. I'm going to 2. I think it's going to make our lives a little bit easier. So I'm going to slide that 3 out in front as a 1/3 and use the constant multiple rule. So the 1/3 stays there, and then I'll use the quotient rule for the quotient. The quotient rule says square the bottom and then rewrite the bottom. Multiply by the derivative of the top, which is g prime of x, minus the top, which is just g of x, times the derivative of the bottom, which is f prime of x. By the way, by sliding this 1/3 out in front, it just kept all our numbers up here smaller. So I think you'll appreciate that. All right, so here we go. We're now going to plug in our 1. So I've got that 1/3 out in front. So I want f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. And now we're just going to get all those numbers from our chart. So f of 1 is 3, g prime is 4, g of 1 is 1/2, f prime is negative 1, f of 1 is 3, and 3 squared is 9. Beautiful. So we really have 1/3, or how about now we could call that something over 27, right? We're dividing by 3 and 9, and we're left with 12 plus 1/2. You can leave that alone, right? At this point, I'm worried about the calculus, not the arithmetic. If you want to get rid of the fractions in there, you could multiply the top and bottom by 2, and you'd get 24 plus 1, which is 25, and on the bottom, 54. So if you want to go all the way, obviously, that's fine. You're going to find in this class, arithmetic is not a stressor for me. The calculus is.